Okay, so let's look at question one of tutorial sheet one, which is saying study the following list carefully. So we've been given a list of both measurements and units, or units of measurements and quantities, physical quantities, and the list has kilogram, minutes, mass, ampere, charge, coulomb, newton, force, time, resistance, luminous intensity, mole, electric current, and the meter. And the question is saying from the above list, pick out all the one base units, which means you're supposed to pick out which ones are base units from these that have been provided with here. We should also pick out base quantities. We should pick out derived quantities, and we should also pick up derived units. Okay, so we've been given how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So from these, we're supposed to allocate them according to these groups that have been given here. So from the topic of units and measurements, I'm sure we discussed in detail what base units are, what derived units are, what base quantities are, and what derived quantities are. So as for base units, the first one here, we know to say these are fundamental units, the many SI units from which all the other units are derived. So which ones of these that are above here are base units? So we have let's see. Okay, so we have the meter. Meter is a base unit. Uh, we also have the kilogram as a base unit. We also have ampere for electric current as a base unit. We have the mole for amount of substance as a base unit. What else do we have? Okay, so it's just these. Only these four are the base units that have been given here. Okay, so if these are base units, that means that we can move on to the next one. Okay, so let's now look at the derived quantities, or maybe let's check out the base quantities first. So what are base quantities? You know, to say these are the physical quantities that are the ones that are going to be expressed in these base units that we have here. Okay, so the base quantities from the list that we've been given, we have uh, mass, one, this one. We have time, two. We have electric current, three, this one. We have what else do we have? We have resistance, no. Minutes, no. Coulomb, no. Luminous intensity. Okay, we have luminous intensity, four. We have four. What else? Coulomb, Newton, minutes. Okay, so that's all on the base quantities that we have. Those are the base quantities that are on this list. We can move on to something else. Okay, let's now go to derived units. So these are units that are derived from the base units that we've already talked about. So of which that we are remaining with, which ones are the base units? We have, derived units, not base units. Derived units, the coulomb is one of them. The Newton is one of them. one of the derived units. And what else? The minute. The minute, to say the base unit for time is the second. So minute can't be a base unit. Okay, that guy. And how many things are we remaining with? We're remaining with force, charge, and resistance. So these are not units. Force, not units. Charge, it's not units. And resistance, these are also not units. So the remaining ones, we're just going to put them automatically under the derived physical quantities. Okay, so on the derived, we have force, product of mass and acceleration. We have charge, guy measured in coulombs. And then we have resistance, which is measured in ohms. Okay, so that's all on allocating these quantities that we've been given into their respective categories like that. So that's question one. We can go to question two, which is saying write the full names, write the full names of the following units. So we've been given these units, and they were supposed to write it, or we're supposed to provide the full names. So we have the the microgram here. You can tell by the symbols. Say that is microgram. Then we have MA here, and then we have the capital M and then the capital A. We know to say on units and measurements, the capital A is for ampere. It's for ampere. And the capital M, don't confuse the or the small m, the lowercase m and the capital M. The capital M, whenever you see it in measurements, that means you're talking about mega. So this is mega. Whilst the capital A is for ampere. When you come to the third one here, you have kk. So there is small letter k here, and there is a capital K. So in units and measurements, capital K is always for the SI unit of temperature. This is the Kelvin. Whilst the small letter k is always for kilo. Okay, and we have the fourth one. N, the small letter n in units and measurements is for nano. Whilst the capital J is for joule. Okay, and then the small letter d, to say this is for deci. And the small letter m, it's for meter, like that. So if I want to write this in full, what am I going to do? Let me go to my blank board. Okay, so on question two, we have these four things, or five things rather. So this is question two. And we have this for microgram. We have MA omega ampere, mega ampere. We have the small k and the capital K for kilo Kelvin. We have N, small n, and the capital J for nanojoule. And we have dm for decimeter. Okay, so those are the names of these units in full, like that. Okay, those are the names for the units in full. We can move on to the next question. Okay, so this question is saying which statement involved or which statement involving multiples and submultiples of the base unit meter is correct? Which multiples and submultiples of the base unit meter is correct? So we have A here, we have A, we have B, C, and D. So which one of these is correct? So just by looking, I'm sure I can tell to say the correct statement from here is the statement number D. D is the correct statement. 1 kilometer is equal to 10 power 6 millimeters or 1 million millimeters. If you want to prove that statement, you can say, or you can go down from the submultiples. You convert millimeters to centimeters to meters until you reach kilometers. Because if I have let's say if I have 10 power 6, which is 1 million millimeters, and then I want to convert these guys to centimeters, I'll divide them by 10. 1 0 will go, I remain with 100,000 centimeters. I divide these centimeters by 100 to convert them into meters. 2 zeros will go. I'll remain with how much? Uh, I remain with 10,000. Wait, is it 10,000? Okay, so it's not 10,000, sorry. It's 1,000 because I'm removing 2 zeros from 100,000. So I'm remaining with 1,000. 2 zeros will go. I remain with 1,000 meters, of which this divided by 1,000 will give me exactly 1 kilometer. So option D there is uh, the correct statement. Okay, so we can move on to the next question. Okay, so question 4 is saying the current through a given conductor is given by the formula I, which is for current, is equal to K A Q V, where A is acceleration, Q is the charge, and V is velocity. What are the SI base units of K? What are the SI base units of K? So this question is from dimension analysis. So this is dimension analysis. Like that, and we are supposed to find the SI base units of this constant K, which is in our equation. So what are we going to do? We'll go to our blank board. Okay, so we're going to go to our blank board here and bring down our equation, which is saying I is equal to K, A, Q, V, like that. And I've told us to say I is for current, A is for acceleration, V is for velocity, whilst Q is for charge. So what are we supposed to do in order for us to find the base units of K? We can just plug in the base units for these other quantities that have been given in the equation. Since all of them, they are known, we have current, we have uh, current with the base unit ampere. We have acceleration with the base unit meters, which is distance per second squared, like that. We have velocity with base units meters per second, and we have charge with the base unit Q or Coulomb, like that. So we can plug these guys into our equation and see what we are going to get, because we are supposed to make K there our subject of formula so that we find what units K is going to have at the end. Okay, so we'll say I, which is ampere. I'll replace I with A. This will be equal to K, and K is being multiplied to what? To acceleration. And acceleration, we have meter over second squared, multiplied by Coulomb, which is the charge, and this multiplied by velocity, which is uh, meters per second, like that. Okay, so we're going to have A being equal to K, uh, M multiplied by M here, or M multiplied by C by M, we're going to get M squared being multiplied to C, like that. And that is over second squared multiplied by second. You're going to get this over second to the power 3, like that. Okay, and when it reaches here, we can continue, because the next thing we're supposed to do uh, is make A the subject. I mean, it is to make K the subject of the formula. So what can we do from here? We can multiply this expression by the reciprocal of this guy that we have here. So what's that? It is going to be S to the power 3 over M squared multiplied by C. So we're going to, this and this will cancel out on the left, even that and that will cancel out. So I'll remain with K being equal to A, and A is being multiplied to what? It's being multiplied to S power 3 over M squared multiplied by C, like that. And I'm going to say K is equal to A multiplied by S to the power 3 over M squared multiplied by C, like that. And that is going to be our, we can simplify this equation further. So these are going to be our base units for K, hence shown. So this is the end of this question, like that. Uh, the next one. So question 5 is saying an aeroplane flies at constant speed over 700 kilometers per hour. Determine its speed in meters per minute. Determine its speed in meters per minute. Okay, so unit conversion. Unit conversion here. And we've been given 700 kilometers per hour. And we need to convert this into meters per minute. So this is very simple. What are we supposed to do? We're supposed to um, just bring our conversion factor. So this is the same as 700 kilometers per hour like that. Then I'll multiply it with the conversion factor for the numerator, which is 1000 meters being equal to 1 kilometer. Then I'll multiply it with the conversion factor of the numerator, the denominator, which is 1 hour being equal to 60 minutes. So the hour and the hour will cancel out. The kilometer and the kilometer will also cancel out. So what are we going to remain with? Remain with it 700 multiplied by 1000. That will be 700,000. This is minutes. 700,000 like that. And this is meters divided by 60 minutes like that. And this should give us uh, this should give us 700,000 divided by 60 should give us 11,666.67. So we're going to get 1100 or 11,666.67 meters per minute. Okay, so those are the units we are looking for here. All right, so we move on to the last question now, which is saying convert the following or convert the following. The first one, we have 300 millimeters. We convert 300 millimeters to these units here. And what are we going to do? Okay, so we are converting 300 millimeters into these units, of which I've said if you have a capital M, that's mega, and the smaller m here is for meter. So we are converting 300 millimeters into mega meters, and mega means 1 million. So what are we going to do here? So firstly, we can convert the 300 millimeters into meters, and we'll do that by dividing it by 1000. That so we'll have 300 millimeters being equal to 0.3 meters. Now, since I've said to say mega is for million, how are we going to convert 0.3 meters into megameters? We're going to divide this 0.3 by 10 to the power 6 meters, like that. And we're going to have, let me just punch on my calculator. Okay, so I'm getting 3.0 times 10 to the power minus 7 mega meters as my answer. Okay, so we'll move on to the second one, which is saying convert 250 kilometer squared into centimeter squared. 250 kilometer squared into centimeter squared. Okay, so 200, 250 kilometer squared to centimeter squared like that. So what are we going to do? To say whenever we're converting units with squares, we are supposed to just introduce a square on our original conversion factor. So I'll say 250 kilometer squared like that. And I'm going to multiply this guy by its conversion factor. And what is the conversion factor of kilometer to centimeter? It's 10 to the power 5, or rather 100,000 centimeters are equal to 1 kilometer. So I'll say 100,000 centimeters are equal to 1 kilometer. Then this is my conversion factor. I'm going to square it like that. So I remain with it 250 kilometer squared multiplied by I'll distribute the square on the numerator and the denominator, and on top I'll get a 1.0 times 10 to the power 10 centimeter squared over 1 kilometer squared like that. The kilometer squared and the kilometer squared, which is here, can cancel out. And we're going to remain with 250 multiplied by 1 exponential 10 square centimeters over 1. So what are we going to have? We're going to have 250 multiplied by this number, which is here. This will give us 2.5 times 10 to the power 12 square centimeters, like that. Okay, so that's all on part 2. We can go to the last question, which is saying convert 135 micrograms to kilograms. Converting 135 micrograms to kilograms. Okay, so we go back. We say part 3. 135 micrograms to kilograms, like that. And what are we going to do? We also know to say if we convert, or we can start by converting the micrograms to grams first, which by so doing, we're supposed to multiply it by, to divide the number that we have here, the 135 micrograms, over 10 to the power 6, because 1 gram is equal to 10 to the power 6 micrograms. So we can multiply this by 10 to the power minus 6. Okay, that's what I wanted to say. Which, in simpler terms, we just divide it by 10 power 6, like that. And this is going to give us what? It is going to give us in grams 0.000135 grams. And now from grams, we know to say 10 power 3 grams make up 1 kilogram. So we can multiply this by that conversion factor. We'll say 10 power 3. Okay, let me do this. Not 10 power 3 there. I should say 1 kilogram is equal to 10 to the power 3 grams. These grams and those grams go. Then what am I going to remain with? I'm remaining with the 0.000135 kgs over 10 power 3. And this is going to give me how much? It should give me 0.0 0.0000135 kilograms. Okay, let me check, counter check. Okay, so 1, 2, 3, 4, 5, 6. Okay, so this is it, kilograms. And that is the final answer, or if not that, you can say 1.35 times 10 to the power minus 7 kgs, like that. As simple as that. So that marks the end of the tutorial sheet. Thanks for watching. You can subscribe to the channel, like the video, comment, and share. Thank you very much. We'll meet in the next one.